Within software engineering, we have to act as professional engineers, and one of the typical tasks of an engineer is to estimate and measure. So we have to measure across the whole development process. So here we have to estimate size of the system, estimate time it takes to develop a software system, and using these estimates we have to plan how to develop the system. But planning and estimating is not an easy task. If you ask someone to describe the size of a building, then you can get a reasonable answer, because a builder can tell you, okay, this building is 15-story high, it has 656 windows, it has 187 doors, it has as many floors, and it has as many pipes, and so on. This is easy and concrete, but this is also the result is concrete. It's a building that is very tangible. With software, there is another problem. You have software requirements. They are intangible. You cannot touch them. You cannot see what size they are. So here we have difficulties in estimating software size based on the initial set of requirements. So many companies have this problem. You have professionals who deal with estimating the system size. Usually what you do is that you simply shoot, either you shoot from the hip, or you use historical data on similar systems in order to estimate the size. And the size may be estimated either in log, which is lines of code, or it may be estimated in other measures such as function points. So we are looking for a reasonable answer how to measure software system size. So we have two types of measures: size-oriented measures and function-oriented measures. And I have mentioned that size-oriented measures are lines of code. What you do with lines of code is that you simply count all the lines. You do not. Some companies count all the lines. It does not matter whether it is a blank line, whether it is an executable line, whether it is a comment. They do so. Some other companies only count executable lines. So there is no some rule how you should measure lines of code, as long as you use the same measure consistently within the company. But the Software Engineering Institute, SEI, has proposed how to measure software size using lines of code, logs. And this proposal is on 200 pages, so I won't be able to present all, but I can tell you that lines of code are specified as by statement types, how they were produced, what was the origin, what is the usage, how they are delivered, what is the functionality of them, how they are replicated, the development status and language. This is simply an overkill for defining a line of code for many companies. But let us have a look at statement type. You look at line of code that it is an executable, it is non-executable, and non-executable line of code is are declarations, compiler directives, you have comments on the own lines, on lines with source code, you have banners and non-blank spaces, you have blank empty comments. Usually you have them so that you can simply make the code more readable, and you have also blank lines. So using this type of information you can define your own lines of code within an organization. But using lines of code is not a very good measure actually, because lines of code in assembly language is not the same as lines of code in high-level language. Let me provide you an example. To develop some functionality, it takes time, but it takes different time if you do it in two different types of languages. Here, in assembly code, analysis takes 3 weeks. Design takes as well the same amount of weeks for both assembly code and high-level language. And this is because you do simply the similar things. There is no distinction between analysis, requirements, specification analysis, and design. But coding in assembly code, it takes 8 weeks, whereas it takes 4 weeks in high-level language. And testing requires much more time. So what happens here, if we look at lines of code, here we have the size of 5,000 lines of code, and here in high-level language we have 1,500 lines of code, which means that you have more lines of code, and that's why you cannot compare the size of systems across languages. What you can do is you can compare with one and the same language, because the lower the level of the language, the more productive the programmer is. It looks at the programmer writing systems in assembler is more productive than the other programmer. The more expressive the language, the lower apparent productivity. It seems that the productivity is lower. And even if you write code in the same language, you may see the differences between the code written by different programmers. Some of the programmers are more verbose, and they may seem to have higher productivity. So, and sometimes less productive programmers may produce high quality code because they have thought through what they were writing. So it's not a good measure, but still it is one that is available, and it is used widely by many companies and even by researchers. But okay, lines of code can be used for estimating the effort to develop a software system. And there are many models suggesting how to estimate the effort. Of course, these models must have some kind of size input as software system size, because otherwise you cannot estimate how much time it will take to develop such a system. So we have one model that is called COCOMO 2, developed by this guy, Barry Bem, and he has created several models within COCOMO. One of them is this one, which estimates development effort, but you can do this estimation after you have created software system architecture. And the input to it, when you have software system architecture, you may estimate how many lines of code you may have for each subsystem, and subsystems, and so on. Using this information, you can then estimate how much effort it is required to develop the software system. There is another group, another type of estimate, which is called function-oriented measures, and these ones are a little bit different. What you do is you do not measure the size of the system by looking at number of lines, the physical side and the size in this case, but you look at the bigness of the functionality, some kind of a logical size of the functionality, and this is called function points. So you give a number of function points to a requirement, for instance, and here you have a formula for estimating function points, so which it consists of unadjusted function points, which then get adjusted with the rest of this formula. And if we have a look at unadjusted function points, so we have here number of parameters that we must consider. So when you try to decide the size, you look at number of user inputs to a certain functionality, number of user outputs, number of user inquiries, number of files, number of external interfaces. You simply try to evaluate whether they are complex they have average complexity or whether they are simple. You assign the value to them, you sum everything, and then you get a total count for unadjusted function point. But this is not enough, because there are many other parameters that must be considered. So let's look at the rest of the formula. We simply have to consider factors like different factors, which we evaluate on the scale between 0 and 5. 0 means that this factor is not relevant, and 5 means that it is highly relevant. So for instance, does the system require reliable backup and recovery? If it requires a very reliable backup and recovery, you may assign number 5 to it. If it does not require anything, then you assign 0 to it. So here you sum all these factors, you multiply them with this, you multiply this with unadjusted function points, and you get the size of the functionality. Function points are used by some companies, but they are not so widely spread. But Ericsson, I know that in some parts of Ericsson they use it for just making sure that they do not only use function points, they may use different models for estimating the size of systems, but they use it as one of the models to make sure that they have estimated in the right way. Okay, there have been war between those promoting function points and those promoting lines of code. And because those who were for function points, they claim that this is the only way to estimate the size. You look at how much functionality you have to implement, and in this way you may be able to estimate the effort. Whereas those promoting lines of code, they claimed no, but this is a very subjective manner, because when you estimate the values for all these parameters, for all these factors, it's actually a subjective thing. You may evaluate them on a scale 3 or on a scale 5, very subjective. But anyway, there have been some research where they have tried to translate how many lines of code gives one function point. So you can estimate, for instance, that, or they have come to a result that one function point corresponds to 350 lines of code. Or SQL, one function point corresponds to 20 lines of code, and so on and so on. I'm not sure whether I like it or not. I'm very happy that I'm not dealing with it, because it's a very difficult subject, and it changes all the time, just as technology changes and ideas change. So I don't think that I would be happy to deal with this. However, this is what it looks like right now. Okay. Barry Bem, as I mentioned, he has several models for estimating the effort, and one of them is this one that is based on function points. So in the early design models, here this one, the second one, the one that I presented before, corresponded to post-architectural stage. Here at the early design stage, you can use function points, and then you can use this information for estimating the initial effort. Okay. But still, even if we have our models, we have difficulties in estimating the size of the software system. Here we have a cone of uncertainty. Actually, we are very 100% sure of the size of our system when we have implemented the system. But before that, we may either underestimate or overestimate the size. And the nearer we are the final result, the better we are in our estimations. So we have to accept that it is difficult to estimate, and we have to actually have very good experience in order to to be able to estimate the size and the effort required for developing the system.